over 200 millimeters of rainfall, the highest since 2015.
As the climate crisis worsens, extreme weather events are becoming ever more common. And these concrete jungles aren't exactly helping.
Infrastructure is impermeable, so often you get flooding because the water's got nowhere to go.
In fact, the industry that builds this infrastructure is making things worse. 11% of the world's carbon emissions come from construction.
We cannot afford to carry on business as usual.
In 2 years, China poured more concrete than the USA did in the whole of the last century.
So how can humans build without it costing the earth?
We have 3 kids. We have their futures to think about, our futures to think about.
Nareed and Muzamel and their 3 kids live in the Bay Area of San Francisco. They bought their house 3 years ago, but now with a growing family, they need more space.
I'm thinking that in order to give us more space in our bedroom, we just build out 8 feet this way. When we bought the house, we had really grand plans to add 1,000 square feet and make it a huge home. And then we spent some time researching and analyzing and really going through it. There's a lot of good things about living with less. There's less cost for heating and cooling, but then that impact on the environment. We really made a conscious decision. We've now scaled it back to about 100 square feet. So we're headed to the primary bedroom.
Without its most problematic ingredient, cement.
Business worldwide simply cannot continue at the current rate. We must find new, sustainable means through innovation and technology.
Materials technology company Betala has spent 5 years working on an answer. Inspiration for the company's cement-free solution came from the mountains of waste being produced by other industries. Using artificial intelligence, it analyzes local industrial waste and generates the right recipes to produce its composite cement alternative.
We take industrial waste, for example from steel production, and we combine it with alkali activating solution. And by this way, we can reduce the CO2 emissions of concrete raw materials even up to 80%.
As well as this potentially huge reduction in the scale of emissions, there are other obvious benefits to using waste products or side streams.
By providing the possibility to use these side streams, we are actually giving a new life for this waste instead of landfilling into the environment.
It's an ingenious solution, but even given the extent of industrial waste, questions remain about its scalability.
Although the steel industry is a huge industry, in comparison with concrete production, it's relatively small. There's just not enough waste materials. They're not going to transform construction in the way that we might want to.
Transforming construction might instead mean weaning the industry of its reliance on concrete altogether.
Hemp is not generally used in construction, and that's got some quite unique properties.
Hemp is another name for a very familiar plant with a colourful history. But unlike cannabis, industrial hemp contains only tiny traces of the chemical that gets people high. It has some other things going for it though. It grows incredibly fast. Its fibres are also surprisingly strong.
What we're doing here is using the woody core of the plant, which is called shiv, and we're just mixing it with lime to make a rigid insulation material. It's fireproof. It also has fantastic thermal inertia, so when external temperatures fluctuate up and down, the internal temperature of the house stays very constant. It's just generally a good insulator, and it's locking up carbon. This is about 300 square meters. So if you scale that up, this house, if it was built in the conventional way, would be responsible for somewhere between 150 and 200 tons of CO2 emissions. We're able to get that to zero, so that's a massive carbon saving at the construction stage, as well as the fact that it will be operationally zero energy going forward as well.
Hemp used in this way can clearly help deliver significant reductions in carbon emissions, but its nickname hempcrete might be a little misleading.
It's an interesting material, but you're not going to build major infrastructure out of hempcrete. You might build an extension or even a house out of hempcrete, but it's not going to compete with concrete as we know it, because it just doesn't have the mechanical.
University School of Architecture, Michael Ramage and his team are taking inspiration from the past to inspire the construction industry to new heights in the future.
Oakwood Tower was a demonstration project and a research project to show that building really tall in wood was possible. So we engineered this 300-meter tower for central London, and we showed that it was possible for it to stand up.
Whilst Oakwood Tower is just a proof of concept, it's based on innovations that have transformed the load-bearing strength of wood.
In the last few decades,
CLT is constructed in a controlled factory environment by gluing layers of wood at 90 degrees to each other. The layers are then hydraulically pressed together, creating high-strength structural panels. Using computer-controlled joinery machines, any shape of panel can be cut before being transported to site.
timber building sites tend to be much quieter than other building sites because they go together mostly with battery-powered drills. Construction is much quicker because the timber arrives on site prefabricated like flat-pack furniture, and it gets lifted into site by a crane. While high-rises are lots of fun to design and an interesting challenge to engineer, most of the buildings that we need are not high-rises and are ideal for building in cross-laminated timber.
But one thing everyone knows is that wood burns. For many, fears would be fueled by the prospect of wood-built cities going up in flames.
Cross-laminated timber is of course wood, and it will always be a combustible material, but we know how to make fire-safe designs in cross-laminated timber. There are a range of different strategies so that fires don't spread if they do start, and so that the wood, in many cases, is not exposed to the fire. It's often behind layers of plasterboard. But one of the big challenges with wooden
Dear future generations, I think I speak for the rest of us when I say, sorry. Sorry we left you with our mess of a planet. Sorry that we were too caught up in our own doings to do something. Sorry we listened to people who made excuses to do nothing. I hope you forgive us. We just didn't realize how special the Earth was, like a marriage gone wrong. We didn't know what we had until it was gone. For example, I'm guessing you probably know it as the Amazon Desert, right? Well, believe it or not, it was once called the Amazon Rainforest, and there were billions of trees there, all of them gorgeous, and... Oh, you don't know much about trees, do you? Well, let me tell you, trees are amazing. I mean, we literally breathe the air they are creating. They clean up our pollution, our carbon. They store and purify water, give us medicine that cures our diseases, food that feeds us, which is why I'm so sorry to tell you that we burned them down.
The giant sequoia that was first weakened by drought was then subject to impacts by the bark beetle, which then further weakened the tree and potentially made it more susceptible to mortality from fire.
State officials warn the threat this fire season in California is dire.